So first, as I always discuss, the physical properties of these elements like your atomic size, ionization enthalpy, electronegativity, electron affinity, all these things we'll be discussing, and afterwards our chemical properties. The very general first characteristic is what? Our electronic configuration. The group 15 elements have the electronic configuration of what? The valence electronic configuration of NH2NP3. Their ionization enthalpy, if I ask you this question, what will be the ionization enthalpy of group 15 elements with respect to group 14 and group 16? What will be the answer? Group 15 elements, because they have half-filled p subshell, you can see it is NP3. That is, each p orbital will be acquiring what? It will be acquiring one single electron. It is half-filled, right? So we can expect that the ionization energy of group 15 is higher than 14. That is by the trend, the normal trend that we observe, and it will be also higher than that of the group 16 elements. Why? Because it is more, you have to supply more energy to take out the electron from the stable half-filled electronic configuration. If you remember this question from class 11, in the periodic properties, we asked this question. It's a very popular question. Why does nitrogen having larger size is having more ionization energy to a smaller size oxygen? So the answer resides in what? In the electronic configuration. So down the group, as you can see, nitrogen is having 2s2 2p3. Its period number is 4, right? Where N represents our N is period number. Right? So as you people know, nitrogen is in the period number 2, phosphorus in the period number 3, arsenic in period number 4, and down the group you can see them that bismuth being the in the period number 6, it is having electronic configuration of valence electronic configuration of 6s2 6p3. Moving further, then our atomic radius. What happens? Going left to right in the periodic table, what happens? The atomic size decreases. Why? Because the electron which is adding, it is coming to the same shell, but what happens? One proton also adds. So the effective nuclear charge experienced by the valence electron is higher. That is why the size decreases when we go from left to right. Right? So group 15 elements will be smaller in size in comparison to that of the group 14. Now, if I talk about in the group itself, what will happen? Down the group, what happens? Down the group, size always increases, right? So, but in this case, we have as we know, P block is full of anomalies. It is full of exceptional cases. So, what happens? What we expect is down the group, the size should increase, right? But what happens? The increase in size is not that much. Why is that? If you remember from the group 13, I asked this question, why size of gallium is smaller than that of the aluminium? The answer was simple. So because of the presence of the poor shielding d orbitals, what happens? The effective nuclear charge experienced by the outermost electrons, what happened to it? It increases. That is why the size either shrinks, the atom, the size that we were expecting, it is less than that. And in case of gallium, the effective nuclear charge is so high that the size of the period number 4 element is less than that of the period number 3 element. Highly exceptional case. Over here, also what happens? Because of the presence of the d orbital, and further in the period number 6, because of the presence of the f orbitals, the size does not increase it does not increase that much. There is increase in size, but it is very less, right? So this question they can ask you in the board's exam. Why does the size does not increase as we expect it to be? Why the size increases less? So that is the answer. Because of the presence of the d and f orbitals, and their poor shielding effect, the effective nuclear charge experienced by the valence electrons is high, and the size does not increase that much. Moving further, so next our trend is of ionization energy. So I've already told you that the ionization energy of our group 15 will be higher than that of the group 14 and the group 16 because of its half-filled electronic configuration. Now, if I ask you, what is the order of ionization energy for the group 14, group 15 and the group 16, right? Think about it, right? So the trend will be group 15 will be the highest, then it will be group 16 which will be higher than that of the group 14, right? Why is that, sir? Why is that? So the reason is because that thing is very clear that the ionization energy of group 15 is going to higher than that of the group 14. The reason is simple, because the size is decreasing, effective nuclear charge is increasing. That is why ionization energy is increasing. But why it is more than but why does group 16 is more than that of 14? Because of its smaller size, right? So that is why we get this particular trend. Now going down the group, what will happen? Going down the group, because the size increasing, ionization energy will be decreasing, right? So that will be the trend of the ionization enthalpy.